Can you solve this integral? To solve this integral, we are going to use a cool little method. I've seen it be called plus k minus k. Basically, what we're going to do is we're going to rewrite our integrand to make it easier for us to integrate. So this integral is difficult to evaluate by itself, but if we take our integrand x squared over x squared plus 1, what we can do is we can add 1 and subtract 1 from either the numerator or the denominator. I'm going to choose the numerator because this will help us simplify this fraction. Now, all we've done here is nothing, basically, because we've added 1 and subtracted 1. Addition and subtraction are inverses of each other, so it's basically the same as adding 0, and we know, of course, that adding 0 has no effect. So we have this fraction, x squared plus 1 minus 1 on the top, and then x squared plus 1 on the bottom. And we can rewrite this as two fractions because we have a subtraction here. So we can rewrite this as x squared plus 1 over x squared plus 1 minus 1 over x squared plus 1. Now, if you were to evaluate this, then it would just be equal to this. So we can rewrite our integral as the integral of x squared plus 1 over x squared plus 1 minus 1 over x squared plus 1 with respect to x. And if we look here, then we see that x squared plus 1 over x squared plus 1 is just equal to 1. So our integral becomes 1 minus 1 over x squared plus 1. Now, this is a very easy integral now to evaluate. All we need to do is just evaluate it as you would normally. So this one would become x. And then this minus 1 over x squared plus 1. I already have a video on how to solve this integral, but this is a very basic trigonometric substitution integral. I'm not going to go into the substitution because I already have that on my channel. You should go watch it. But this is just equal to minus, because we have a negative sign there, inverse tangent of x. And then, of course, as we're doing indefinite integration, we have to add our constant of integration. And that is our answer.